Algebra 2, this is a video of the homework answers for lesson 11-6. So if we're looking at question 1, they want us to see what the expression tangent of theta cosecant of theta is equivalent to. So tangent of theta, remember, is just sine over cosine, and cosecant of theta is 1 over sine. So I highlighted these a little. All I'm doing is taking tangent of theta, which I have highlighted in yellow, which is really just sine over cosine, and I'm multiplying it by cosecant of theta, which I have highlighted in green, and cosecant of theta is 1 over sine. And you can see I have sine on top and sine on the bottom, so those can cancel out. So it's equal to 1 over cosine. So that is equivalent also, but that's not one of the choices. And do remember that cosine is the inverse of secant. So this is equal to secant of theta, choice 2. So that's really what you're doing in these. You're just figuring out what it's equivalent to, playing around with it a little bit. So if you look at question 2, tangent of theta I have on top. Remember, tangent of theta is sine over cosine. Secant I have on the bottom, and secant is 1 over cosine. So this is what you have when you have tangent of theta over secant of theta. Remember, when you're dividing fractions, you take that denominator, and you flip it and you change to multiplication. So this division is going to change to multiplication. You see the multiplication right here. And I flipped the 1 over cosine, now becomes cosine over 1. And then the cosines cancel. Okay, so that was a rule that you learned probably back in middle school. When you're dividing fractions, that denominator, you change to multiplication, and that denominator, that second fraction, you flip. So this is choice 4. Number 3, I have secant squared of x. Secant squared of x is really just 1 over cosine squared of x. Cosecant squared of x is really just 1 over sine squared x. Now, how do I know to even do that? Look at the choices that you have here. None of these choices have secant or cosecant. They're all either 1 in the first one, or there's some variation of cosine and sine. So I'm changing the secant and the cosecant to their inverses, 1 over cosine squared of x and 1 over sine squared of x. Now this one's a little bit harder because you're adding them. So you can see this secant squared of x is 1 over cosine squared of x, and cosecant is 1 over sine squared of x. Now you can't add unless you have the same denominator. So the common denominator that I'm going to use is sine squared x, cosine squared x. So that denominator is right here. So in order to get that denominator, I am multiplying for this first fraction. I'm multiplying the numerator and the denominator by sine squared of x. And I'm allowed to do that because sine squared of x over sine squared of x is really just 1. So essentially, you're just multiplying by 1. You're not changing the value of this at all. So when I do that, sine squared of x times 1 is sine squared of x. Sine squared of x times cosine squared of x is cosine squared x, sine squared x. And then I'm doing the same thing to the second fraction. Remember, I'm trying to look for a common denominator of sine squared x, cosine squared x. So in order to get that denominator of sine squared x, cosine squared x, I need to multiply the numerator and the denominator by cosine squared x. So 1 times cosine squared x is cosine squared x. Sine squared x times cosine squared x is cosine squared x, sine squared x. Now that my denominators are the same, I can add these fractions together. So I'm going to add the numerators, which gives me sine squared x plus cosine squared x. And I'm going to keep the denominator, cosine squared x over sine squared x. Now remember, for my identity, sine squared x plus cosine squared x is really just equivalent to 1. So that's how I get 1 over cosine squared x, sine squared x. For 4, I want to show this as an identity. So secant squared theta is really just 1 over cosine squared theta. Tangent squared theta is sine squared theta over cosine squared theta. These are 2 fractions. They have a common denominator, so now I can combine them together. 1 minus sine squared x is 1 minus sine squared x. And actually, I changed these to x. I should have kept theta the whole time, but that's okay. Cosine squared x is the denominator, so that stays as a denominator. You're not adding those together. Remember, 1 minus sine squared x is really just equivalent to cosine squared x. That's the same thing we were doing over here, and that sine squared x plus cosine squared x equals 1. 1 minus sine squared x is equal to cosine squared x, and since I have cosine squared x over cosine squared x, that is equal to 1. So I got this whole left side to equal to 1, and the right side is already equal to 1, so I show that that is an identity. Using the identity sine squared theta plus cosine squared theta equals 1, find the value of cosecant theta to the nearest hundredth if cosine of theta is negative 0.55. So I'm going to substitute this in for cosine. So I'm using this identity right here. I highlighted cosine squared theta in yellow. I'm substituting in negative 0.55 because that's what cosine of theta is equal to. I'm squaring it. So sine squared theta, I take this and I move it over to the right, is equal to 1 minus negative 0.55 squared. I put that in my calculator and I get 0.6975. Now I'm trying to solve for sine of theta, so to get rid of this squared, I take the square root, but if you take the square root of one side, you have to take the square root of the other side. So this equals sine of theta and the square root of 0.6975. Now I am in the third quadrant and I drew a little chart right here. So all students take calc. In the third quadrant, only tangent is positive, so sine is negative. So this is negative square root of 0.6975. And the cosecant is what I was trying to find out. Cosecant is 1 over sine, so it's 1 over negative square root of 0.6975. And I put that into my calculator, and I did get negative 1.20. All right, 6 is stuff we've done previously, but just not with cosine. So I have f of 90. So let's substitute 90 degrees in for the f function. So right here, f of x is 2x. So f of x is 2x. I'm substituting in 90. F of 90 equals 2 times 90, which is 180. All right, now I'm going to do g of what I just found. F of 90 was 180. So see how I got 180, and I'm just substituting that in for the g of x. So g of 180 equals, g of x is cosine of x, so I'm substituting in 180, and cosine of 180, if I draw a little graph right here, I can do it with my calculator, but if I draw a little graph, 180 is right here. That point is negative 1, 0, and cosine is the x coordinate, so cosine is negative 1. And then number 7, I want to do f of 30. So I'm substituting in 30 for x. So f of 30 is 10 times sine of 30 minus 3. Sine of 30, we have that memorized, is equal to 1/2. 10 times 1/2 is 5, and 5 minus 3 is 2. Okay, so those are the answers to lesson 11-6.